Hello, this is Dave from Dimensional Consulting. Today's video is about go and no-go gauges. First, we will look at go and no-go gauges for regular features of size where rule number 1 applies. A go gauge is a fixed limit gauge that checks a feature of size for acceptance within its MMC perfect form, rule number 1, boundary. The go gauge must be at least as long as the longest part so the entire part can fit inside it at once. If the part fits inside the go gauge, it meets its rule number 1 requirement. If the part does not fit inside the go gauge, it fails its rule number 1 requirement. A no-go gauge is a fixed limit gauge that checks a feature of size for violation of its LMC actual local size. If the no-go gauge does fit around the feature of size, it fails its LMC requirement. If the no-go gauge does not fit around the feature of size, it passes its LMC requirement. Here we see the part fitting into the go gauge, verifying that it meets its rule number 1 requirement. Since the no-go gauge is rather thin, it must check the part in multiple places. If the no-go gauge can fit around the part anywhere, it fails its LMC requirement. Here is the go gauge for an internal feature of size. The MMC size perfect pin must fit through the entire hole to verify the rule number 1 requirement. The fixed size gauge represents the mating part. If the gauge fits into the part, then the mating part will fit into the part. That is how rule number 1 protects the function of assembly. The no-go gauge for an internal feature size is a little more complicated. A fixed size gauge would verify that the LMC requirement is met at the ends of the hole, but the center of the hole must also be checked. This is a gauge that has retractable pins. The pins are retracted, so the gauge can be moved to the center of the hole. Then the pins are released. If the released pins crash into the walls of the hole, the part has met its LMC requirement. But if the pins are able to expand all the way, then the part has failed its LMC requirement. In this example, the straightness tolerance with the MMC modifier overrides rule number 1 and creates a virtual condition boundary. The go gauge has a hole in it the size of the virtual condition boundary. Since the no-go gauge checks only for local LMC sizes, the no-go gauge is the same as it was when the part did not have the straightness tolerance applied. Here again, the straightness tolerance with the MMC modifier overrides rule number 1 and creates a virtual condition boundary. The go gauge is a perfect pin the size of the virtual condition boundary. Since the no-go gauge checks only for the local LMC sizes, the no-go gauge is the same as it was when the part did not have the straightness tolerance applied. A go-no-go gauge can also be used for a profile of a surface tolerance. Here we see a profile of a surface tolerance applied to the complex surface between points A and B. This figure shows the 1Y tolerance zone centered on true profile. The gauge has surfaces to contact atom features A, B, and C. We create a gauge surface an arbitrary distance from the true profile of the surface we are measuring. We choose to make our gauge surface 1.5 from the true profile. This means that there is 1 between the MMC surface and the gauge surface. There is 2 between the LMC surface and the gauge surface. Therefore, our go gauge is 1 diameter. A 1 diameter pin must always fit between the part surface and the gauge surface. Our no-go gauge is 2 diameter. A 2 diameter pin must never fit between the part surface and the gauge surface. That's today's video. If you want to see more tips like this, please subscribe and visit my website at dimensionalconsulting.com.